All right, good morning. I think we'll go ahead and get started here. My name is Warren Formo. I'm the Executive Director of the Minnesota Agricultural Water Resource Center. And one of our programs is Discovery Farms. Tim Raditz is our technology guru and coordinator for the Discovery Farms program. You'll hear from him a little bit later. But I want to start out this morning with a welcome to those who are here in the room and also those who are joining us via Zoom. And I want to talk, first of all, give some thank yous. This project that we're going to learn more about today wouldn't be possible without a lot of partners. And so first, I want to thank Farmamerica for not just for hosting us for this meeting today, but for their participation and allowing us to be part of this tile project and to conduct the research that we're going to be conducting here over the next couple of years under the current grant, and hopefully for a number of years after that as we explore other questions related to tile drainage and good agronomic practices. So first of all, that huge thanks to Farmamerica. Second, thank you to NRCS. This project has been in the works. We've talked about it for 5 or 6 years, but it really wouldn't have gotten off the ground had it not been for state conservationists Troy Daniel, Dave Jones, and others at NRCS stepping up a little over a year ago and providing the initial grant that provided much of the funding for this project. So we appreciate NRCS for that. Also, Prinsco. Prinsco was the tile provider for this project, and you'll be hearing from Prinsco reps a little bit later, and you'll see some video that shows the actual tile installation. So thanks to Prinsco for that. Our monitoring partner through all of the Discovery Farm Network is the Minnesota Department of Agriculture, and they also will be doing the monitoring work for this project, setting up the equipment design and collecting the basic water quality information for us. So we have Scott Madison and Yaba Kiersgaard here today, and you'll be hearing from them a little bit later as well. And then also we get significant funding for our Discovery Farms program from the Minnesota Corn Research and Promotion Council. And so without all of those partners working together, a project of this size and scale wouldn't be possible. So just a few words about the project from my perspective. At the Minnesota Ag Water Resource Center, our basic purpose is to help farmers advance their stewardship and help communicate that story to non-farmers who have an interest in agriculture. And I would say that over the 20 plus years I've been involved in this sort of work, the single most contentious issue in Minnesota agriculture is around tile drainage. There are very solid beliefs on both sides. And the critics of tile drainage will tell you that it removes too much water too fast, carries nutrients and contaminants to surface waters. Proponents, generally those who understand agriculture differently as an agricultural production and conservation practice, credit tile drainage for actually reducing peak flows, for reducing sediment losses from ag lands, reducing phosphorus losses, with the trade-off that we have to recognize that tile does become a conduit and a potential way for nitrates to reach surface waters. Not necessarily a new loss of nitrogen, but a new pathway. In these poorly drained, these soils that have poor natural drainage, nitrogen losses are probably bigger in an undrained or a poorly drained condition, but it's going the other direction. It's coming off as a gas, not affecting surface waters. So over the next couple of years, our hope is to explore, in this case, controlled drainage or drainage water management, which is a project or a process you'll learn more about through this morning, which allows us to control the water depth at parts of the year, not drain as much as a conventional drain system would do, and find out how much less water will these systems contribute downstream, how much less nitrogen would be delivered. And so we'll collect actual data at field scale to help answer those important questions. So our initial phase here, we've got multiple zones and monitoring ability built into this project. You'll hear more about that from the experts who know more about it than I do. But essentially what we're trying to explore is, does controlled drainage make a contribution to conservation and protecting the environment while enabling efficient production? And then subsequent to that, we often hear anecdotally from farmers who are trying to do more advanced conservation practices like incorporate cover crops or reduce tillage intensity. They will report that having good uniform drainage under the field is important so that you don't have wet spots here and there that, excuse me, that will affect your ability to do those reduced tillage practices. So this was a field that was previously tiled. It's not a newly tiled field. but now it's tiled different. It's tiled with drainage water management engineered in. It's tiled with modern standards for how much water can leave the field. So we believe there will be a significant benefit there, and we're going to capture that story over in the coming years. So with that, I will stop, and I'm going to turn things over to Tim, and we're going to have a panel and some other folks come up and talk a little bit more detail about the project. So again, thank you all for being part of our morning.
All right, sorry for the clunkiness and switching speakers. Warren, can you hear me on the Zoom feed all right? All right, well, thanks Warren for that introduction. Thanks everybody for being here today. I'm gonna start off talking a little bit about tile drainage and what we're looking at here. I can't go to a meeting and not talk about tile drainage and moving water because I'm an ag water engineer. So what are we talking about when we're looking at tile drainage? There's many potential benefits. Warren covered a lot of those. Better plant establishment, growth and yield, timeliness of field operations, and also that reduced surface runoff and soil erosion. So by removing some water from the top of the soil profile during different times of the year, we have the ability to infiltrate more rainfall in certain times of the year as well, which can reduce surface runoff and soil erosion, which is really important. However, there is potential concerns too, and Warren touched on this a bit. And this is primarily with the conduit of soluble nutrients to surface waters. And in particular, with tile drainage, we're looking at nitrogen and nitrate. So that's our main concern when we're looking at water quality in tile systems. So if we're thinking about what water tile removes from the soil profile, you can think of your soil as a sponge, right? With about half pore space, half solid material. And that pore space can either be filled with air or water. And having it filled with all water and saturated, no good for plant growth. Having it filled with all air and no water, as we've seen in the last few years with the drought conditions, is really not good either. So what sort of water does tile remove? If we're looking at soil water, we're only removing with tile that saturation when all the pores are full and water is draining freely with gravity. So it gets to a certain point where there's pore space and pores in the soil that put a suction on that water, on that soil water. And our tiles don't have the ability to take water out after it gets to field capacity, where there's no longer gravitational drainage of that water. So we're not removing the whole portion of soil water, it's only a fraction, but it's really important to know that that saturation to field capacity is really what we're trying to manage with tile drainage. Now we've been collecting data at Discovery Farms for, since 2007, so quite a lot of years, makes me feel old. And we've been collecting data at a number of farms across the state where we're doing surface water monitoring and tile monitoring at the same place and on the same field. So this data kind of represents all of those sites across all the years. What do we see compared surface to tile when we're looking on the same field, same spot? So if we're looking at runoff, which would be in the top left, runoff and tile drainage, about 3/4 of the flow on a field comes through the tile, compared to about 1/4 through surface runoff. Soil loss, almost all through the surface runoff, hardly any through the tile. We just don't see a lot of soil movement through our tile systems. Similar to phosphorus, which is in the lower left. However, the story switches when we get to nitrogen, where we're seeing most of our nitrogen movement, in particular nitrate, move through our tiles and not through our surface runoff. And what affects the amount of nitrogen we move through our tile system? Really, it's heavily dependent on the amount of flow. So the more flow we get, the more soluble nutrients we move with that flow. And so this is a graph of annual tile flow of all our sites across Minnesota versus annual nitrogen loss. And it works out to be about 4 pounds per acre nitrate for every inch of drainage. So if we can limit the amount of tile flow, we could limit the amount of nitrogen loss. That's sort of what we're looking at here. And what we're looking at here is drainage water management. And this is kind of a diagram showing the structure. So it's a structure that we can manipulate the water level during different times of the year and try to hold some of that water back and reduce some losses. And so the goal of this project is to increase adoption of drainage water management by providing demonstration and evaluation of this practice. And with this site, there's going to be 4 different spots where we're going to have the ability to control or not control drainage. And the idea would be to, for the first few years, not control anything, or for the first year, so we get some baseline data. And then after that, control 2 of the basins, so we're holding water back, and not control the other 2. So we have some sort of comparison from controlled drainage to conventional drainage. And with that, I'm going to show a video of the project that we did some taping of when we were installing, so people can take a look at that.
Tile drainage is a tactic many farmers use to help them manage water and achieve maximum productivity. A large-scale research and demonstration project at Farmamerica near Waseca involves the installation of a controlled drainage system on nearly 120 acres of farmland.
And essentially what we're trying to do is gather more information for farmers, landowners who have an interest in tile drainage, make sure that we're showing the modern principles of how drain tile is installed, which is much different than in the old days. And also then collecting data so that farmers can make better decisions, whether it's about how they manage water, how they manage nutrients, how they manage soil, the type of tillage they do, and it just helps support farmers in their management.
Conservation drainage has become a lot more prevalent in Minnesota. Minnesota has got a lot of agricultural lands that are drained by drain tile. And the old way of doing that was put the drain tile in the ground and let it run out to an outlet, and that outlet go to surface waters, lakes, rivers, and streams. We've decided that there's potentially a better way to handle some of that water, and that's where the term conservation drainage comes from. What are we going to do to treat the water? How can we make agriculture sustainable yet protect our water resources?
The project has been years in the making and involves numerous partners, including the Minnesota Agricultural Water Resource Center, the Natural Resources Conservation Service, the Minnesota Department of Agriculture, Prinsco, Ellingson Companies, Farmamerica, and more.
Prinsco has always been involved in supporting research and what's going on with regulatory issues and what's the best thing to do on the farm as far as managing your water.
For us, it gives us an opportunity to talk about the impact that tile can have economically to soils and farms like this. So it's we look forward to telling that story here.
The site offers an opportunity to gather data on a field-scale project to learn more about how controlled drainage can impact water flow and quality while demonstrating what's possible.
Prinsco, as a pipe manufacturer, we manufacture water management solutions, and it's sometimes challenging to find projects where you can do research and development, just because, like I said earlier, not everybody wants you to play in their field, right, and practice. So this is a great opportunity to participate, with our peers, with the other groups like this, and get something meaningful done.
I think it's going to be extremely valuable. I think farmers out here, really will gravitate towards, a research project of this size, because, they can come out and say, well, geez, they had, whatever, 40 acres or 50 acres of corn here, or soybeans, or whatever they were growing, and, here were the results from applying this practice, and I think they're going to feel, very very secure that, you know, these numbers are accurate.
I think it's really important to recognize that this isn't a small project. It's really quite large, a lot of partners, and they're very diverse. Having Farmamerica as the landowner here and their willingness to add this piece to their story about the evolution and how agriculture continually strives to be better, having them involved so that we can collect this information with them and we can host field days here to get crowds of people who are interested in the topic to come and actually share the data, look at firsthand at what's going on in the field. There's no substitute for in-field learning. And you can share a lot of information in a classroom or in a wintertime conference at a convention center somewhere, but being out in the field and seeing what's happening is really important.
Control structures have been installed to help adjust the water table in the field. Monitoring equipment will also be implemented to help Minnesota Department of Agriculture staff and Discovery Farms monitor water flow and water quality for years to come. The Farmamerica Tile project has taken 8 years to get from concept to reality. The project went through a rigorous approval and design process.
And so the landowner has had to work with the local NRCS and a drainage authority to get approval for all the things that are happening here. Then beyond that, you've got engineering and surveying to make sure that these tiles and the laterals that run under this field are laid out properly and in really the most efficient way.
The Farmamerica site is divided into several zones. Control structures will allow farm operators to adjust the water table to potentially lower water levels when they need to get into the fields for planting, or to hold water back so it's available in the soil when crops need it.
Drainage research has been done on a much smaller scale, and to get on a field where you can, you're wide open, you can start over and create what you want to create is really an important step. We're starting to see that research be more on a field scale, and that's really exceptionally valuable to researchers and for us to figure out what's going on with the economics and the production and also the water quality.
Farmers don't want to remove any more water than they have to. We only want to remove enough to grow a crop successfully. And the new systems that are out there using GPS satellite technology, we can install it quicker, more accurate.
The process of designing any tile project has changed through the use of technology and intricate mapping. Projects are engineered to be as efficient and effective as possible.
The contractors involved have equipment now where they can survey entire farms right in a day, right? They can do a lot of work actually from information that's public information on topography. So there's tools out there today to make these projects more feasible, right? They can get things done faster, more efficiently, which is another reason why I think controlled drainage, because it does take more design work, probably has a lot of legs in the future.
Tile drainage is often vilified for rapidly moving water and nutrients off the land. In reality, modern tile drainage systems are designed to slowly meter out excess water, allowing the soil to hold as much moisture as possible. This actually makes conservation practices like strip tilling or no-till farming and cover crops more feasible.
They work hand in hand with each other. We create a sponge in the soil profile to absorb excess moisture. The only moisture that does get removed from the soil profile is water that does not adhere to the soil particles. So we do have, it is a conservation and agriculture thing, and very, very productive for agriculture and good for everybody.
I think the potential benefit of controlled drainage is where we have more control of what water is moving off that field through tile. So there'd be certain times through the year where we can shut off that tile drainage and try to hold some of that water back, and in turn, reduce the amount of water leaving the field, but also reduce the amount of nutrients that are contained in the water that is leaving that field.
And my experience as a farm management instructor, as an ag teacher, and even as a farmer, When I see water ponding in a field in June from poor internal drainage, I get really nervous because that nitrogen will nitrify up in the atmosphere, or it's going to be associated with that and go down through the drainage. And then when we see all the rain events that carry the phosphorus out, with soil particles, and having good internal drainage to control those things, to me that is better conservation, holding the phosphorus in place and keeping the nitrogen where it belongs in the soil profile to be used later.
Tile installation is a major investment for landowners. For any farmer to consider installing systems like the controlled system going in at Farmamerica, it has to make conservation and economic sense.
Typically, in 5 to 7 years, a drainage system is paid back in full from when it's installed. And your biggest payback, of course, the number one thing, of course, is yield. That will show up quickest. But also intrinsically, you're going to see a reduced cost in fertilizer and crop protection product use because your soil is releasing nutrients available to the crops better so that they can utilize with less. And that's less product we're putting on and potentially less issues of contamination going into the water systems.
Because the controlled drainage systems involve more engineering and equipment than standard subsurface drainage, the Farmamerica project will analyze economics as well as water quality.
I think that's what we're going to figure out is not only the water quality benefit of these controlled drainage systems compared to conventional drainage systems, but the potential economic impact. With these newer controlled drainage systems, are we going to be able to hold water back during certain parts of the year where we could potentially, the crop that's growing in those areas could use that water that we're holding back, where in conventional drainage systems you wouldn't have that opportunity. So those are the things that we're testing with these plots at this project.
One of the focal points for the Farmamerica Tile Drainage Research Project is to learn more about how much water actually leaves the landscape. When water flows through the tile, monitoring equipment will automatically take quality samples and measure the flow.
This tile drainage project will help us better measure and understand exactly how much water leaves the landscape. We can make comparisons between managed or controlled drainage, where we seasonally change the water table, and what is traditionally described as free-flowing or conventional drainage, where those systems can function anytime there's excess water in the soil profile. But also it'll help us understand better, typically in Minnesota, how many days do tiles not flow? That's really important.
We're looking to see, first of all, what kind of particularly nitrate and nitrogen load is coming from the tile drainage, and then looking at how we can manage that with the controlled drainage to reduce the amount of nitrogen load and the amount of flow. This particular field drains to the Seward River watershed, which is actually one of the highest nitrogen loading streams in Minnesota. So the concerns with tile drainage typically are the quantity of flow and nitrogen. And with controlled drainage, you're kind of addressing both of those issues. If you can reduce the amount of water or drainage from the farm field, you're also going to reduce that nitrogen load.
Now, the real world data is what really interests NRCS currently, and that would be from the standpoint of, is there data out there? Yeah, there's a lot of data out there, but there's not a whole lot of data out there in our environment. It's very important to us to gather regional data, and I think this is a fantastic opportunity to have that happen.
We'd like to learn more about how drainage can be a support for emerging soil health practices like cover crops. Farmers often report that they can get in their field in a more timely manner and get cover crops planted, and they get established better. And so going forward, if we can collect more information over a number of years, that would be really important. And so we hope that we can capitalize on this significant investment over, maybe the next 10, 15 years. All right, thank you. So just a quick word. First, I want to thank everybody who was part of that video. That's fun. I think you guys all together, we told a pretty compelling story. So I want to thank everybody who was part of that video. And also, I should have had a better list. I neglected to mention one of our partners, and you saw their equipment in the video multiple times, but the folks at Ellingson Drainage also contributed to making this project happen, not just doing the work, but providing a lot of expertise and help to get this project underway. And so I appreciate the folks from Ellingson's, and Mike Tweeten will be part of the presentation this morning on the panel, and you heard from Roger Ellingson earlier. So thank you to all of you folks. So I'd invite our panelists to come up. Gene, come on. Sure.
All right. Let's get you guys on camera first. You're so camera shy. So I'll let you guys introduce yourselves first. I can't talk and listen to myself at the same time. I'll let you guys introduce yourselves first. A little bit about who you are, who you work for, and what your role was in the project. So Carl, let's start with you.
Hi, my name's Carl Getter. I'm the agricultural segment lead for Prinsco. Prinsco is a water management company. We operate all through the Corn Belt as well as on the West Coast as well. Our role in the project is we were a pipe supplier. We provided almost all the drainage material needed to buried underground.
Mike Tweeten with Ellingson. I am the Director of Project Management, and my role in the project is I oversaw the project, the planning, and the installation.
I'm Gene Coonson. I'm the farm manager at Farmamerica. I've been here for 7 years. Prior to that, I was a farm business management instructor for 20 years in southern Minnesota. My role in the project is kind of helping make sure that people are here and trying to coordinate things. And but I had a lot of apprehension prior to October. But in 10 days, this thing just went together just like that. And now we just got a lot of marks out in the field that we've got to screw around with before we can start thinking about planting a crop. So.
All right, Gene, let's stick with you. You said you had a lot of apprehension. If you could talk a little bit about from the farmer or landowner's perspective,
Well,
like what your thoughts were
okay.
going into this project, how it went, and how we hopefully solve some of those apprehensions.
Prior to coming here, I spent a couple of years with the Cannon River Watershed Partnership as a consultant, and I got called in on several things on drainage around the Cannon River area, and I was introduced briefly to controlled drainage. And I'm trying to think of now, you put wood chips in a burrito in the ground.
Bioreactor.
A bioreactor, okay. And so I know the difference between those two, and was asked, I'm glad I did, because it was asked several times by MDA, we're going to put a bioreactor. And I said, no, I don't think so. We're just going to stick with controlled drainage. And so that's how it kind of went. But a lot of my apprehension is based on ignorance about tile drainage. And yeah, I understand tile drainage. I know what it does economically. And I've never had a farmer over 20 years ever have to borrow money on tile. It got paid for in cash because it paid for itself rapidly. And just the fact that yield monitors increase that appetite for tile drainage as you go across the field. Yield went up in an area that we pattern tiled. Well, that's direct response, and that works. So I know it works, but understanding some of the mechanics, as I observed tile being installed this fall, and some of the lights went on, but I'm just ignorant about how it gets installed and what it's supposed. I know what it's supposed to do, but I've still got some apprehension about, okay, how are we going to control that with the gate? I have no clue. I'm loaded the control boxes, watch them put a few in, but after that, I'm dumb. So I'm looking to be enlightened today somewhat, so.
When you were looking at this project, you've been looking at it for a while. Was there some benefits you saw to controlled drainage compared to conventional in terms of the farmer aspect of it that you thought were very positive and a reason to kind of take on this project and be annoyed by all of us sitting around?
Well, no, I, over the years, over the last probably 10, 12 years, when we look at these typically large rain events and there's been some finger pointing. I mean, I come from Waterville and there was a big meeting after Waterville flooded and a lot of fingers got pointed at farmers and tiling, you know, that's why we flooded in Waterville. I'm going, oh, well, okay. So there's, and my knowledge about controlled drainage to me makes sense. Holding back what you need to, only letting out what you want to let out. Makes sense in terms of those large events, but we have a poorly drained farm here, run poorly drained soils. Finely textured and a tile system that's Mike, what do we figure was 70, maybe 60 years old. At least clay tile was shallow, ineffective. And every year we had a wet year, forget it, 10%, 15% of your yield went in. 5 acres on the West 120 last year were underwater during the year, didn't provide any corn, any beans on those acres. And to me, that it's all about getting those perennial wet areas productive again. So that's where I'm at.
All right, thanks. Now let's switch on to more of a questions about controlled drainage design and considerations when we're looking at controlled drainage projects. What are some things we need to assess? Say I'm a farmer or landowner looking at this webinar and thinking, boy, I wonder if I can do this on my land. What are some things in terms of slope or soil types that might be limiting for doing these sorts of practices on a farmer's land?
Sure, I can start and I'll let Carl chime in. With every drainage project, topography and soil type is a major consideration in the design. Excuse me. Even more critical in controlled drainage. When you're trying to manage a water table, slope is the number one factor, followed closely by soil type. The more slope you have, the tougher it is, the more cost comes into play. Ideally, if the world was flat, this would be a practice that would be widely adopted across all agricultural land. Unfortunately, we don't have that. And as you can see on this project, the design complexity increases as the topography changes. So soil type, same thing. You know, we're trying to hold a water table. Some soils are more conducive to that than others. So that's the considerations we look at when we design these. Anything you want to add, Carl?
I would just add that, you know, if you're a farmer looking at whether or not this will work for you, it doesn't mean you have to completely start new with an entire new system. If you're a farmer and you have a 40-acre parcel or an 80-acre parcel or even a quarter, and you maybe already have part of it pattern tiled, part of that quarter, part of that system will probably qualify, will probably be eligible, or you can implement a management practice, possibly even with the tile you already have there. I would say that across the Corn Belt, I mean, a lot, if not most of the farms probably have a portion of the farm that will qualify. It lays nice, it lays right, the pipes aren't installed at too heavy of a grade already, and you can possibly implement by just adding the control structure.
So there is opportunities for like not a complete redesign, whole new installation. There might be opportunities on certain farms, certain landscapes where you could just retrofit a system that you already have installed.
Absolutely. If you had your system designed and it was designed well, and you have some records to show you what your slopes are, you may be able to take just a portion of that farm, or maybe just a low bottom that you pattern tiled, add a structure somewhere. Now you may have to farm around that structure if you can't get it to the edge of a field. Whereas if you design new, you try to put those structures in areas that'll be easy to farm around, right?
Sure.
But absolutely, there's retrofit designs possible.
Yeah, and so if we're looking at conventional drainage versus controlled drainage, and we're laying these systems out, is there a significant difference in terms of the tile layout and maybe the amount of tile that goes into the ground when we're looking at conventional or controlled drainage systems?
Yeah, I mean, historically, conventional drainage is designed for efficiency. You know, you're looking for longer tile runs, which may put you more perpendicular to the contour than parallel. That is quite the opposite in a controlled drainage environment. You know, we want to try to parallel that contour. You know, the goal with that design is to control as much of a zone as possible per box, you know, because that is where a good chunk of your cost comes into on this thing is how many acres can you control with each structure.
Yeah. And in terms of having the capacity to design, because it's sort of a newer project or newer practice, would you say there's a capacity, you know, across tile installers in Minnesota to design these sorts of systems, or is it more of a specialized sort of deal to get these systems designed right?
Good question. So at Ellingson, we're fortunate to have an in-house design team, which ultimately gives us the capacity to tackle these type of projects. Typically, there's a lot of drainage contractors that don't have that dedicated staff and they're designing and installing. But we do have some companies out there that are working on this type of stuff, third-party design firms. So I would highly recommend a design prior to installation if you're looking at controlled drainage for sure. This isn't something you want to try to field fit for sure. That being said, you know, obviously reach out to your contractor or the local NRCS and they're going to direct you in the right way to get this thing planned properly.
Okay, great. And when we're talking about installation of these controlled drainage projects, could you compare and contrast? Like, is the installation more difficult compared to conventional drainage? Or is it easier, similar?
I'd say different, not difficult. Again, what I said earlier about conventional design, you know, we as drainage contractors design for drainage and efficiency. So we're looking for, you know, longer tile runs, minimizing connections. The topography dictates design, so you lose some construction efficiency in putting these projects in. We're still just installing drain tile, but it's just different. As you've seen on the video, the lines are not straight. You know, drainage equipment is designed to go in straight lines, so we lose some speed in install. And then also the structures, you know, those are not on a typical drainage system, so there's time and effort going into installing those as well.
Yeah, for sure. And Gene, could you talk a little bit about those structures and maybe, you know, how we planned to stage them so you could actually farm around them, because they can be quite of an issue if they're put in the middle of the field and you have to kind of work around them.
About the only part of that I can answer, Tim, because I just don't know how they're gonna even look inside of one before it got put in. But anyway, we've all got up on the west side of the field. We're gonna put a permanent perennial rye, probably 30-40 feet wide, to drive alongside that. So to monitor the equipment, and then, you know, just you lose 30 foot of field, no big deal. But
But that's mostly for our monitoring team,
right.
so
And
we
we'll
can access it and
probably keep that in there forever.
yeah,
Just to keep equipment off of it.
sure. And also the structures we ended up going with are manual structures. There are some automated structures. But for our monitoring purposes and what we had going with this project, we went with the manual option. So it's going to take somebody manually going out there and manipulating those boards, not necessarily an automated process. So always going to need access to those. Okay, a big thing, if I was a landowner looking at this practice, would be cost considerations in terms of, say I want to tile this piece. and I'm interested in controlled drainage, how much more extra is it going to cost me? Is it going to be 15% more extra, 20% more extra? Is there any sort of numbers that you guys have that could give us some insight there?
Sure. So let's break that into two pieces. So let's start with if it's a retrofit system. If it's a retrofit system, and again, you have good documents, you know where your tile is, you know how it lays. Really, the only additional cost you're going to have is installing the structure. So you have the cost of the structure, and then also the cost of whatever you pay someone to put it in. So depending upon the size of the field, how big those control zones are, it's going to range all the way from about $20 an acre to $100 an acre, depending upon how many structures you're going to need, if you have to add any additional pipe to do anything. If it's a new system where you're going to start from scratch, really, if the field lays decent and you don't have a bunch of design considerations, you're really not using any more pipe than what you would have in a standard pattern tile system. So you'll still only have the cost of the structures and any other maybe miscellaneous costs that might go with it. So it's not a ton more, even on a new system. Maybe you raise that up to $40 to $120, with the average maybe being 50 to 60, somewhere in that bracket. And then anything else that you may have to do. So relatively speaking, if you're looking at a new pattern system, might be anywhere from, I mean, they range, right? But say $700 to $1,200 an acre. Really, to add this practice and give yourself some ability down the road to possibly add additional water management practices. If you think about anywhere from $40 to $120 an acre, in my opinion, it's not a huge number, but everything is relative. So.
Sure, but the additional costs pretty much from the control structures and the time to put them in, not necessarily more pipe is what you're saying for conventional versus controlled.
Right. You know, we're a big advocate of doing a good design up front. And if you're already going to do a good design up front, you're going to have the field surveyed and you're going to have it professionally designed, which you know many contractors can do. There's also private guys that do that. If you're going to do that already, your pipe is already, the spacing probably isn't going to change unless there's some other design criteria you're working towards. So if your spacing's not going to change, really the amount of the footage of pipe you're putting in per acre isn't going to change. You may have a few extra connections, as Mike referred to earlier. We maybe can't go with as long a runs as we would have in the past. So you may have a few extra connections, a few extra T's, some other miscellaneous fittings. But at the end of the day, the type of pipe that you use isn't going to change. You're still going to use the same pipe that you would, that's dictated really by your soil type rather than the management practice you're going to use. So none of that really changes.
Okay. Well, that's great. And I was poking around on you have the water table website that you guys operate. And I noticed there was some tools on there that landowners could go to, and actually got to a place where you could go look up a map and zoom into your land, and it would tell you if your land, based on your soils and your landscape, is suitable for this type of practice. Is that something you guys have seen before or used?
Yeah, so that map you're referring to basically shows all the land across the Corn Belt, and it's colored in red, the land that would be that should be able to utilize water management. It is on our water table website. I think you can also find that on the University of Iowa Extension has it listed. I think the Purdue University has it listed. I think Ohio State University, and a handful of other companies that just try and help people understand the benefits of water management. So
sure,
it's a tool that's out there.
Yeah, and I think it was useful for me, just in terms of if you're a landowner or a farmer, just saying, oh, I wonder if I need to do a tile project. I wonder if this would even be a consideration on this 40 or this 120 or whatever, this quarter. That may be a good first place to check and see if your land is colored red to see if it would work in your area.
It's a good spot. I think Purdue University actually has about a 10-page question and answer document that's out there. If you just Google search control water management question and answer, it'll pop up as probably one of the first few listings. And it does a nice job of going through not only that piece, but also some of the economic considerations, other things that you may have to think about on your property as well.
Sure.
Some great tools out there.
Great. And so, gonna put you guys on the spot a little bit. So we're doing all this big project, looking at this control drainage, different plots. I want to hear from your guys' perspective in terms of what you do in your professional lives in the industry, and as a farmer too, what your biggest concerns are with this project in controlled drainage, in terms of what you're maybe wondering if it's going to work or not. And then also what you see as the biggest potential benefits for what we're doing out here with this project.
Sure, I can start. As far as concerns go, when I read the question, I'm like, I really don't have a lot. It's a good practice. We've been putting these in for a long time. If there's anything that comes to mind is, number one, it's management. Management of the system and management of expectations. Landowners need to really understand what this will and will not do. And, with the design, what are you actually controlling and what aren't you controlling? Because, again, I'll come back to the topography thing. There's certain designs where you're not going to be able to control the whole farm. It's just not feasible from a cost perspective. So understanding that there's only certain parts of that farm you are controlling and managing those expectations. Second part is managing the system, knowing that you've got to move some gates, whether it's manual or automatic, and staying on top of that. We have seen in a couple instances where, somebody forgot to open some gates or was late to open them, and there is some detriment to the crop if you're not on top of that. So that's really my only concern.
Right. It's just another thing.
Yeah.
You can forget to manage, right? Or, there's enough going on in everybody's life where to be able to remember that.
To build on that just a little bit, it's not something, as far as the management piece, it's not something that we can give someone necessarily just a cheat sheet, right? Where they can say, okay, 2 days prior to a rain, it's got 90% chance of rain tomorrow, 2 days prior, we have to open, because it is somewhat soil dependent as well. So soils that let water move freely, right? More coarse soils, you may be able to do it 2 days in advance. If you're up north and you've got some heavy clays, you may have to open your gates. Like if you're talking about before you start planting this spring, you may have to be out there a week or maybe a week and a half in advance. So, it's a little bit of an art as well as a science as far as how that controls. So the management is a concern. Another concern could be, depending upon the year, depending upon precipitation, how much water you're releasing, there could be the potential for a minimal amount of sediment buildup within the system, which should get flushed out after you open the gates or the water starts flowing more rapidly. And then the structures themselves, just the fact that guys do have to farm around them. Guys have been eliminating intakes themselves just due to the hassle of farming around them. So I think, again, getting the design properly up front, trying to get those control structures to the side of the field, to the edge of a road ditch, to maybe it's just to set aside along the dredge ditch, getting those in a position so that they don't get a bad name in the farm group, I think is important.
Dean, do you have any thoughts? I'm sure you have thoughts.
Well, just on the design, I'm pretty confident that, and like I think Warren mentioned early on, is that this whole effort started 6 years ago. And we had an initial design put together, I want to say 4 years ago, and the gentleman who's running it from NRCS Salt died. And so it sat in limbo for another year, and then finally got some wheels under it again. And last April, we had our first consulting engineer from Des Moines who did the design work, and then we probably saw the first design in June under the initial NRCS grant for this process. And then that design was looked at by one other engineer, and then Mike looked at it again. He said, well, that's interesting how they did that. And I think that initial design ended up kind of controlling. It kind of ended up being a design based on the contour. So I'm really confident about that because it's went through several different designers. And in terms of controlled drainage, in terms of managing it and watching it, I guess my goal is that we control some of the early season rain so we can get in a timely fashion and plant. Secondly, and then I really don't think there's much of an issue after August. Late July, early August to worry about a corn crop absorbing water. It will absorb it. You know, we've got plant material there, except for the flooding issue. So, but it's watching those 1, 2, 3 inch rain events is, to me, that's going to have to be the big challenge. So,
Sure.
yeah.
We do have a couple questions online, and if there's anybody in the room that has questions, feel free to speak up. But I had a question on lifespan of conventional versus controlled in terms of if they last, these sorts of systems, so you put them in at the same time, designed one conventional, one controlled. Is there different life expectancies for each system, or is it pretty similar?
Sure. So from a material standpoint, so strictly a material, we're using polyethylene pipe on both systems regardless, right? You look at a 99-year service life, so it should be not your problem. Let's just put it that way. It should be our next generation's problem. But I think there's an additional piece to that. And that is that on a conventional system, obviously you just have drainage in mind. Whereas with a controlled drainage system, we may be able to already think about what the next phase might be. What's the next practice we're going to want to use? So let's say that next practice might be subsurface irrigation. So if we have that in mind as we design the system, knowing we already have the ability to stop the water, now we may be able to eliminate additional work that has to be done down the road and want to implement the next phase.
Sure.
So I would venture to say life expectancy of the material, obviously same. But as far as life expectancy before you have to re-enter the field to do some additional modifications, it might actually be longer with controlled drainage.
Okay, great. And then this one's for Mike. If I heard correctly, Mike mentioned that conventional drainage runs straight. Does controlled drainage operate more efficiently, better in non-straight lines?
It's all topography based. If we're talking about a project we did in North Dakota, those lines are gonna be straight. The reason these are curved is because of the contour and the topography of the land.
Mm-hmm.
So that's the reason behind the curved lines, speaking to this application.
But efficiency is the same in terms of if it was straight lines or curved lines, similar?
Yeah, the
efficiency?
design, if you're talking drainage coefficient,
Probably.
yeah, it's the same.
Yeah. Okay.
Yeah, install efficiency is a little less. That when I talk about straight versus curved, it's the tile plow wanting to drive straight much quicker than it will around curves.
Yes. Which can be challenging.
Yep.
Yes. Great. Are there any additional questions in the room? And there's a few of us here.
So I have a question for Gene. I know that since you've taken over as farm manager. Get a microphone here. So Gene, since you've taken over as farm manager, there's been a transition from traditional or full width tillage prior, and now you've worked towards a system with strip till. And could you tell us, you know, with the current drainage system, you mentioned that there are some holes in the field for yields and some wet areas. Do you anticipate that maybe this newly installed system will help you with your efforts to do strip till and reduce tillage intensity?
Oh, I would hope it would. It's taken me 4 years to figure out where all the wet spots are, you know, I mean, and I don't kill them because we just haven't. We strip tilled for the last 4 years. My concern about soil health is we have to walk away from that for a year because we've got to get the ridges worked in. We got to go back to conventional tillage this year and then back to strip till. So, yeah, I would hope and anticipate that that's just one move in direction of good soil health. So, yeah, should enhance it, I hope.
Great.
Dave has one.
Oh,
Thank you. This is more on the operational side. Controlled drainage implies that there's some sort of operational goal. And you had mentioned that we've got control structures. I'm not sure how many. But what is the operational goal what drives the removal of boards or the installation of boards, and at what level is that? Is that a 3-inch board, 4-inch board, 6-inch board, 1-foot board? How much can we navigate that?
Sure. So I believe on the control structures that you have out there, I believe they're 6-inch boards. There are several different available, but I believe the ones that you have are 6-inch. And the operational goal obviously is to keep the water table, out of that top, whatever you determine as your target depth of profile. So raising them and lowering them, obviously there's no benefit to pulling them out in the wintertime or even in the early spring. So again, it's not necessarily a science as far as how quickly you have to pull those boards to achieve that. Obviously, the one nice part about the control structures, you can open them up and look inside. So you can see exactly if you have your boards up at 3 feet and the water is slowly running over the boards, you know with relative certainty that that's where your water table is at. So I mean, there is a visual kind of inspection you can do per se, because yours are manual pulls, I believe.
Yep.
And then where you set them after that, is somewhat based on soil type, somewhat based on exactly where you want that to be. From a design or a material standpoint, we don't really get into that piece. That's more on the management of the farm itself. Does that answer your question?
To add to that's trafficability. Obviously you're going to manage the water table to make sure if you got to get out there and do some sort of an operation that you're not hurting the soil by operating in wet conditions. That'd be the other thing I'd add to that.
Okay, Carl, I've got a question then. So moving ahead this year, I heard we're not controlling any drainage. So are we pulling boards?
Yeah, we just won't put in boards.
Okay. So, and I've figured out over the years here how long it takes us to get back out in the field after an inch rain. And good trying. I mean, it's generally 3 days. You get back out there. It's amazing. So for me, observing those structures during the season might be important for me to get a baseline of what the capacity of that soil is. I mean, are we 30 inches down, 36 inches down, 4 feet down? I mean, my brain's gonna, I'm trying to figure it out.
Is it something in terms of the management of these structures when we do these sorts of projects? Do you start off with, say, whoever designed it will come up with a plan to manipulate gates? And then based on the landowner and farmer knowledge, can you then critique it or change it to make it work for that situation? I mean, I'm sure there are some sort of, based on soil types and landscapes, you can have some sort of base plan in terms of when to raise them, when to lower them. But after that, it's more up to the farmer to kind of make those choices.
Yeah, I mean, drainage water management needs a plan. And that falls on the designer to give you some baseline criteria, exactly what you said. The other thing that comes into play is the drainage coefficient. We talked about it earlier, that should hold fairly true if we know what we're doing. And that's something you can use too, Gene, as you're looking at this. If this thing's on a 1/2 inch drainage coefficient and you get an inch of rain, it's pretty simple math to figure out what the drain down is going to be in a conventional fashion.
Sure.
But the delta will be, how does that drain down occur when we are trying to manage the water table?
You mentioned drainage coefficient, and that intrigues me a bit. So in a managed system versus conventional, would it be more advisable to have a higher drainage coefficient so you get a quicker response to your management application versus undersizing it for maybe a traditional 3/8 inch drainage coefficient, so to speak, and have a slow reaction? Is there a benefit to maybe installing a little bit on the larger side, I guess is what the question is, for a managed system versus conventional system?
Yeah, I would agree. I would agree completely. It's an insurance policy, to your point. The drain down will be quicker if you increase that drainage coefficient. Typically, like you said, it's a 3/8. I believe this system's designed on a 1/2. So yeah, I think that is a real good rule of thumb.
not a question, but I was just going to add a comment. Listen, this is interesting listening to you discuss kind of how you'd learn about the system and then manage it going forward. And as it's been talked about, the plan is to not manage the system the first year. And then after that, start to, at some point, when you've gathered baseline data, start managing 2 of the systems or 2 of the zones and not managing 2. Tim will tell me to be quiet if I'm out of bounds here, but Gene can actually monitor how much water is trickling over those boards without getting muddy and going out in the field because of the information that Scott is at the Department of Ag is collecting. Any of us could go online to our website and we could look and it will tell us how much water is trickling over those boards. And I don't know if it's real time to the minute or if it's a little bit of a lag, 30-minute lag. And so if Gene's curious, you know, is there a big amount of water flowing over those boards or a trickle? He can actually go online, as can all of us, and see exactly what's happening there. So that might help too. Not that every farm will be managed or monitored like that, but while this is, it could help inform some of those management decisions.
And also, I think a benefit with this project and our extensive monitoring is there will be a weather station on the field. So we will know how much it rained really locally, what the temperatures are, what the soil moisture conditions are. So, which you won't get on every project, but with this one, it should help.
Yeah, was that data from weather station going to be available by an app on a phone or online or?
It's a website.
I'll hop on in a second.
Oh, great.
I think what they're saying, Gene, is a lot of people here helping you. You can't screw it up.
The lights are coming in. I'm a lot less anxiety.
All right. Well, any other questions? I think we're good. Well, I'd like to thank you 3 for joining us today and being put on the panel and answering questions. I think it was very helpful. So thank you very much. You're next, right? Next up, we have Scott and Madison. Why don't you put that on? With the Department of Agriculture, and he's going to talk a little bit about the instrumentation that we have set up here at our controlled drainage project at Discovery Farms. So give me a minute, Scott, and I'll get this set up for you.
Slowly fading.
Warming up.
Yep.
All right, everyone good to go?
All right.
Sure you're on camera.
All right. Thank you, Tim. Good morning, everyone. My name is Scott Madison. I'm a hydrologist with the Minnesota Department of Agriculture. I work out of the North Mankato office. I, along with my coworker, Katie Rasmussen, she's out of the St. Paul office. We are the ones that install all the equipment at the Discovery Farm sites and do the maintenance and work up the data at the end of the year, calculating loads and working up the flow data. So today I'm going to talk about the equipment that will be used out at these Farmamerica plots and then the methods that we're using. Oops, did I skip one? All right. So yes, we're using fully automated monitoring stations. Monitoring is conducted year-round, 365 days a year. For tile drainage, you know, in the past, typically what we'd see is this time of year until late June, early July, we'd be monitoring flow. But with the climate, the past several years, it can be almost the entire year where we get tile drainage, or you can have last year where we had maybe 2 months of tile drainage. So it's just all over the place. But snow melt period is the most labor intensive, and that's primarily due to access. it's snow like this year and mud and just getting out there. And then we have a lot of samples to collect. So we collect water quality and quantity, weather, field conditions, soil, like temperature and moisture, which I'll be getting into all that. For this project, Department of Agriculture will be collecting the samples. Often for Discovery Farm sites, we work with local soil and water conservation districts. But because of the proximity to Mankato, it's only about a 25-minute drive, we'll be collecting the samples out here. So first off, starting out with the flow monitoring and capturing the tile flow. We're using, as was talked about earlier, AgriDrain level control structures, going to be used for the water drainage water management. What we use them for at this site and other Discovery Farms is an access location to get into the water, to take the samples, and then to do our flow monitoring. All of the structures, the 4 structures we'll be monitoring out here are, there's 12-inch tile going into them. They're going to be 8 foot in height. So the important, probably one of the most important things is the water level measurement. So we're using our primary instrument. It's called an OTT CBS bubbler. And what that is, it sits up in an equipment shelter. It's like a little air compressor. It pumps up every minute. It pushes a bubble down a thin diameter tube into the bottom of the AgriDrain. And based on the pressure it takes to push out that bubble, it'll calculate the stage value. So that runs every minute, and then it takes a 15-minute average. So we'll have stage data every 15 minutes. And then what we've learned in the past from our sites is sometimes we've got power issues, lightning strikes, things that happen that take out our data logger. So we've gone to other backup devices. We're using this Solence level logger as a backup. It's just a probe that you put in the AgriDrain structure. It records the stage every 15 minutes, and then we just go and download that every couple months so that we have that backup, because getting the flow data is a really critical piece of this whole project. Once we have that stage data, we convert that to a flow value using a rating curve. And you can see on here, we're using these 45-degree V-notch stop logs that have a steel plate on the front. These are from AgriDrain. There's been rating equations developed by Dr. Andy Craig for AgriDrain from Iowa State University. So he has 2 equations. There's an equation for flow that's through the V-notch, and then another equation for flow that occurs once flow exceeds the V-notch to this flat part of the board here. We're using Forest Technology Systems data loggers. These data loggers, we've been using them the past 12 years. They work really well. They're SDI compatible, and that just means that they work with most all the weather and soil instruments that are sold on the market right now. Just standard protocol used for instruments. So along with the stage, everything else that we measure will be at a 15-minute interval, except precipitation. That's actually recorded every minute that it occurs. The water collection, we're using ISCO brand automated samplers and doing flow composite sampling. So in the bottom of each of these automated samplers, we have a 2.5 gallon bottle. And the way it works is we set these to trigger based on flow. So every 100th of an inch of drainage from these plots, it'll trigger that auto sampler to take 125 milliliters, which is about half a cup of water. They'll pump half a cup of sample into that 2.5 gallon bottle, and it just keeps going every 100th of an inch of drainage. So after 56 pulses, that's what fills the bottle. The program's complete. So 56 pulses represents about 0.56 inches of drainage. And these samplers are running constantly when drainage is occurring. As far as laboratory analysis, we send all samples for all sites, all 12 years that we've been running here, to Minnesota Valley Testing Laboratory in New Ulm, Minnesota, to be consistent. And this is a list of what we analyze for: total suspended solids, total phosphorus, orthophosphorus, And then the big one here will be nitrate, nitrogen, ammonia nitrogen, total color nitrogen, and chloride. We developed this list back in 2010, looking at what was being monitored for the Wisconsin Discovery Farms program, and also talking with the Pollution Control Agency. And basically, all three projects were monitoring for the same constituents so that we can compare what we find at the field scale to what's in the rivers and what other projects are collecting. So we operate on the water year, which is October 1st through September 30th. So at the end of September, in the fall of the year, we work up the data, we correct the flow data, combine that with the water quality data and calculate loads. So it's the mass of each of those constituents that I showed to the last slide. We take that mass and divide it by the acreage to come up with pounds per acre, which is the yield. And then a flow weighted mean concentration, you divide the load by the total flow that occurred, so you get an overall average concentration for all the water for that water year. And then what we call runoff or drainage. So the depth of water or the amount of water that went through that agri-drain structure, if you were to spread it out across that watershed, what would that depth be? Precipitation, we summarize that by minute, 15-minute, daily, and monthly, and also compare that with 30-year normals for the nearest National Weather Service station. So all this data that's shown on the slide, it's summarized by year, monthly, and then we also look at the loads when the soil is frozen as compared to when it's non-frozen. Power and communication, we're using 12 large 12-volt marine batteries with 110 watt solar panels. All sites have cellular modems. We're using Campbell Scientific Cell 210 modems. They're on the Verizon network. And then the automated download occurs every 30 minutes. I'll skip that one. We're also monitoring weather conditions and soil conditions. So we're using an electronic tipping bucket. So that's got a tipper inside of it. So when the rain occurs, it goes down into a funnel and hits this tipper. Every tip represents 1/100 of an inch of rainfall. And as another method to confirm those values, and in case we have equipment problems, we also have manual rain gauges at the sites. For weather, we're doing air temperature and humidity, solar radiation, wind speed, and direction. And that weather station will be located at a central located location, probably the southern of the two northern plots. And then soil temperature and moisture probes are installed at 6-inch and 24-inch depths. Something new that we started using a couple years ago are nitrate sensors. Back 5 years ago, the sensors that were on the market were $25,000 to $30,000 a piece, but the prices have really come down and there's been competition and more sensors available. So back in late 2021, we started purchasing these at MDA. I'd say half of the Discovery Farm sites now have nitrate sensors, and all 4 of these plots will have nitrate sensors. We're using Nicotrios or Ecoen. 2 different brands, but it's the same sensor. They just stamp their name on it. They're roughly $9,000 a unit, and the measurement range is 1/4 to 30 milligrams per liter, and that's typically the range that we see in tile drainage in Minnesota. And it's got good accuracy, plus or minus 5% plus 0.5 milligram per liter. I just threw a plot on here. This isn't Discovery Farm site, but this is a site in southeast Minnesota where that blue is, I think I just threw on there like the last month. It's a tile drainage site. The blue on there is flow and the red is nitrate. So you can see the level of data that you can get with 15-minute interval nitrate. It's important that we document what's going on in the field. So we use time-lapse cameras, set at a 3-hour interval. We test to capture the snow melt, when planting occurs, tillage occurs, harvest, and the progression of the crop throughout the year. So this is the slide we were talking about earlier. Where is this data located? This is where you'll find it. MDA, we have it's called Contrail website. It's mda.onerain.com. So this is all of the MDA sites that have modems we put on here, and we separate them by project, and they're showing a different dashboard. So if you, on the top of the screen, if you select dashboards, you'll see one for Discovery Farms Minnesota, and that'll show the data for all the Discovery Farm sites. And that's where this data will be located. It'll include all the weather information, the provisional stage and flow data, and then the data from the nitrate sensors. Another nice feature of this website is we can set it up to do alerts. So if the battery voltage gets low or a sampler triggers, it'll send a text or an email to you. So Tim showed this slide, but I just wanted to bring it up again. I put circles on here. These will actually be where our monitoring equipment will be installed. And then the weather station, I think right now the plan is to stick it right here, centrally located location. That's the southern of the two northern plots. And as was discussed, this first year, we're going to leave everything in free drainage. And this is an example of how we'll look at the data. So pretend these are the two northern plots. That blue line would be what we call a calibration phase. That would be 2023, where we're comparing the amount of drainage between the two plots throughout the year. This could be a daily comparison. This could be a monthly comparison. But what we want to do is we want to plot that. We want to see how the drainage compares between those two. And then starting in 2024 and after, once we go into the treatment phase, we call it, where we're controlling one of the two plots. Again, we'll do that same comparison, which will be this red line. And what we're looking at is to see if there's a statistically significant difference in the slope of those two lines. And then using that to estimate the reduction in flow that occurs. So next steps, just Monday I was out, finally got out there, got the V-notch stop logs installed. Prior to that, there was snow covering the field, couldn't even find the structures. But now we have the V-notch stop logs installed and those standalone loggers. As conditions allow, we will get out there and install the main equipment, which will be the equipment shelters and everything else. So that'll be sometime in April. So with that, I thank you, and so we're ready for Yaba.
There is a question
Oh, okay.
for you. How many Discovery Farm sites are there in Minnesota and elsewhere? I don't know if you want to
I
touch
can't
on
say elsewhere,
Minnesota.
but this is, so we have a site in McLeod County and Wright County, a long-term site. And then a few years ago, we added a paired watershed site in Redwood County. And then this spring, we also added another paired watershed site in Stearns County. And both of those those paired watershed sites are looking at cover crops. So where one part of the field will have a cover crop and the other will not. So this would be the sixth actual project area that we're looking at right now.
Currently, yeah.
Currently.
So in the
And-
past, we've done monitoring throughout Minnesota from northwest to southeast. I think we've been on 15, 20 farms, something like
Yeah,
that,
something like
somewhere
that.
in that range. And we just had a multi-state Discovery Farms meeting earlier this week. There are a few other states, and this goes to your question about elsewhere. There are a few other states that do this type of work as well, and call themselves Discovery Farms, and that would be Wisconsin, where the program originated at. Arkansas and the state of Vermont actually started a program as well. So there's a number of other states and sites throughout the US that are looking at these questions and doing similar monitoring. All right, any other questions in room?
Where's the closest national weather station?
I do not know. I've not looked. I think it is probably Waseca. It might be at the research center.
There's another question online about how is the actual tile and installation paid for on Discovery Farms? So this is a special project where we got a grant for the tile and installation. We typically, as Discovery Farms, don't install tile. We typically set up monitoring equipment on already installed tile or surface water monitoring equipment. And our funding comes from the Clean Water Land and Legacy Amendment through the Department of Agriculture. That's how Scott gets to work with us, and that's how they pay for monitoring equipment. But we also get funding through the Minnesota corn growers on our Discovery Farm side to pay for a lot of the things that we're doing. Any other questions? Yes, so specifically for Farmamerica's funding was through a grant from the NRCS. I think it a CIG or SIG money? It was just a state application, yeah. So almost all the funding for this project came from the NRCS. We also cost share it with some of our internal funding through Discovery Farms, so utilizing some of our previous funding sources. And I know Farmamerica is also contributing some in-kind money. Yes, and Prinsco and Ellingson's contributed with the tile installations as well. There was some discount on the agri-drain structures as well for this project.
Yeah, the initial grant we had proposed with NRCS and was approved. I believe the way that worked was 100% of the control structure costs would be absorbed, but we would have to absorb the tile cost at Farmamerica. So that was on a cost share basis.
So this year, the balance of 2023, you're still going to have your monitoring equipment installed. You mentioned you were on a water calendar year. I wasn't aware that was a thing.
Yeah.
So do you need a whole nother year so you get a full calendar year without any control?
It's not so much year, it's how much flow we get this year. If we get 2 months of flow, it's not going to be good. I mean, it'd be nice to have as much flow as possible for as long as possible.
Is it flowing?
Yes, it is flowing. Yeah.
Yeah, so when we do Discovery Farms projects, we end up collecting a lot of zeros because there's a lot of days that we don't get flow, which is okay for our knowledge. But in terms of pairing these sites up, we need flow to do that. So as Scott was saying, if we get a lot of flow throughout the year, we should have enough data to move on to the treatment phase. However, if we have a year like last year, it might be tough.
Well, I think when we were out there, like early in the process of figuring out where all the lines were, is that your operator said that was the wettest profile he's hit all fall.
It was the first farm we had water in the tile in 2022 fall.
Yeah, so we have a set, there was, yeah.
Yeah, it took till December to find water in the tile last year.
Well, this is an old lake bed. That's what we're dealing with.
So we should have water, is what you're saying.
Oh, yeah.
Yaba's up next, yes. Yes.
Please. So up next, we're Yaba Kiersgaard, researcher at the Minnesota Department of Agriculture, is going to talk about a project. And so as means of introduction, this is a really cool project. I hope everybody's getting excited about it as I am, to look at controlled drainage here in South Central Minnesota. The Department of Agriculture has a very similar project that's been going on for several years in northwestern Minnesota in Wilkin County. And the two are set up so that I think over time we're going to be able to compare our information and look at it. It'll be very important. But the big thing I want you to keep in mind is we're looking at data from a project in Northwest and South Central. The 30-year, the average difference in rainfall based on the 30-year averages is a foot. So we're looking at a relatively drier place and a relatively wetter place. And I think that's going to be really important. But Yaba is going to come up and share some information from that project.
Yeah, I'd be happy to. Thank you, Warren, for that introduction. Yeah, not only are we seeing quite a substantial difference in the amount of rainfall, but also, of course, the amount of flow in the tiles, but also the timing of when we have the flow. So here in more of a southern Minnesota conditions where we might have flow during a longer period in the spring, maybe 3, 4, 5 months, 6 months even in a wet year, and a little bit in the fall again. Up north, we typically have our spring tile flow only over the course of 2 and 2.5 months. So we just have a shorter period where we have flow. And even though the annual amount that's coming off is lower than here, but when it's flowing, that the actual volumes might be similar. So again, my name is Jakob Kjærsgaard. I'm a research scientist with the Minnesota Department of Agriculture. And so I'm going to talk about this project that we call the Red River Valley Drainage Water Management Project. I want to recognize some of my colleagues that are helping with this project as well. And so just briefly, what I'm going to talk about here the next 20 or so minutes is give a little bit of background of this particular project, introduction to the site, give an overview of the controlled drainage system that were installed and some of the findings. And then I'm going to talk a little bit about some of the outreach activities we have, because I think that's equally important on top of certainly the actual data we're collecting, but also getting the information to people, to decision makers, policy makers, and others are equally important. And I think we've had some success with that. So I'm going to talk a little bit about that also. Did I run out of battery? Oh, we'll do it that way. All right. So this particular site is located in northwest or west central Minnesota in Wilkin County, near Breckenridge, Minnesota. It is in the Red River Valley, the southern end of the Red River Basin. So the landscape is very flat up there. We actually do have. We work with the farm we work on. It's the Jared Nordic farm. We do have 2 locations that we are looking at. One is what we call Section 16, where we have controlled drainage, and then we have Section 24, where we have both controlled drainage and a saturated buffer. But today I'm only going to talk about Section 16. Don't know, maybe Tim, I'll need to ask you to advance. So yeah, so it's just Section 16 we're going to talk about. The overall objectives when we set this project up was to look at these different drainage conservation practices, controlled drainage being one of them, and looking at both what are some of the water quality impacts, water quality benefits, but also water quantity, not least because we are in the Red River Basin, drains to the Red River, which flows north, and flooding, especially spring flooding, is an issue. And so one of the thoughts here were, well, can some of these practices actually help reduce the risk of flooding? And can we store additional water in that soil that could kind of have a meaningful impact on the risk of flooding? What I also want to mention, maybe just step back one, is that I've listed all the partners on this project on this slide. And I think that's really important, because when we started this project and started talking about this conversation with the NRCS, and we started talking to different groups about it, both industry, conservation districts, contractors, and others, that everybody said, you know, we think this is a really good idea. We might not all have the same opinions about drainage, but we think this is really important to study some of these things. So everyone we have here, you know, we both have Prinsco, ADS, another tile manufacturer, AgriDrain, Tightline with the contractor. From the industry side, we have the Buffalo Red Watershed District, the Wilkinson Water Conservation District. On the conservation side, then the Department of Ag and the USDA, as well as Jared Nordic, the farmer, and then Gemco Pump Systems and the University of Minnesota. Everyone came together and said, we want to be part of this, and we want to contribute either materials or funding. So everyone listed there has put something into this project. Next slide, please. And so we talked about controlled drainage already, but so here's another graphic just showing what it looks like. And I think I think it is certainly important, again, on the graphic on the left is kind of the traditional conventional system, free drainage, no control on the outlet. So if there's excess moisture in the soil, it'll drain through that tile line. On the right side, we have the controlled drainage where we have a controlled structures located there near the outlet. And then we have those stop logs or boards that can be inserted to help raise or lower that outlet elevation. And so that's how we adjust the amount of water that is in the soil. And so we've had some comments already about, well, how do you manage that over the year? And Gene, you had brought that up as well. And so the way we do it at this particular location is that after harvest in the fall, and when all fall field operations are over, we do put in stop logs and keep them in. So that'll be the situation on the right, keep them in over winter time. So we're draining less water in the winter. And then when spring rolls around, and it will freeze, not this year, we had enough snow, the frost is not as deep, but we had a year where at least the water that was sitting in it, that upper part of it would freeze. And of course, we can't pull logs out until that thaws. But what Jared Nordahy likes to do is that he looks at the water level in the river, the Red River, and when that has crusted in the spring, or crested in the spring, excuse me, that's when he likes to pull the boards out, because he want to hold water back to kind of reduce the contribution of water from the field. And so we pull them out, and we pull them all out. So we have a system on the left. He gets in, does all his tillage, spraying, planting, all that. And when he's done with the spraying, we put the stop logs back in. So that'll be sort of late spring. We put them all in. And then the idea is that if there's any excess moisture in the soil, that we're holding that back within the root zone so that it is available to the crop later in the growing season, especially up in that part of the world that we typically have too much moisture in the spring, but then once we get into the second half of July into August, we might run a little bit short. So the idea is to hold some of that moisture back, and that it will be available to the crop later in the growing season. In theory, we would be removing a stop log one at a time. Our stop logs, that was a question that came up. We have 5 and 7 inch tall stop logs. So that's what we have to work with. And so our original plan was to remove them as the crop develops, the roots start exploring more and more of the soil, that we remove them just to keep that water table below the root zone. In all practicality, what we have found is that unless we have a big rainstorm, that we actually don't have to remove the boards, because the crop takes up the water as it's growing. And so we've had summers where we ended up at the end of once August rolled around, we still had the stop logs in, because there was no need to remove them because the water was taken up by the crop. But it's really important to go out and I think it's really a good learning experience to go out and pop the lid off and look into the control structure during different times of the year, because you can see, well, where's the water table now? And especially if you have a big rain coming through, and we've had that, where you do want to go out and lift the gates or lift the boards just to drain some of that extra water out in the summertime, even when the crop is at full water uptake mode, just so you don't saturate the roots and start pruning off some of those lower roots out there. And then if there's any water left, or if there's any water later in the growing season, we do remove the boards so we can get in, Jared can do the harvest and all that kind of stuff. And then again, after harvest, after field operations, we come back in, put the boards in, and then the cycle continues. So that's how we manage it at this particular location. Take the next, please. So the location we have here is somewhat comparable in size to the one here at Farmamerica. It is a quarter section. We divide it into 3 areas, if you will. We are sort of looking, standing south, looking north at the site here. The top third, 46 acres, we left without any subsurface drainage. So it's all surface drains still. So scrape swales that'll allow the water to drain. Then we have the middle piece that's free drainage, and then we have controlled drainage in the southernmost third. And the black lines horizontal on the screen here, that's the tile lines. Since it is the Red River Basin, it is well, the ground is flat, but there's a little bit of slope to it, but that we could run straight lines. So this was just like you would do a normal tile system. For the controlled drainage piece, though, for each control structure, you typically raise the water level in the soil about 1 foot. That's the amount of what you should be raising it. So on the controlled drainage piece from, or I should say the outlet of the system is in the lower left corner, so the southwest corner of the field. But because we have an elevation difference of about 4 feet from, or a little over 4 feet from the lower left corner to the upper right corner of the controlled drained area, that means that there's too much slope for us to control with just one control structure. So therefore, that controlled drained area is divided into 4 zones, each managed with a control structure. And so those control structures are those little greenish discs at the bottom there. So each of those 4 zones is controlled with a control structure. And then at the lower left area, that's where we have our monitoring equipment. That's where the outlet is. We have a lift station on it. And we have all the monitoring equipment similar to what Scott was talking about. And
are the other water heats underground step up, or are they actual above ground management?
Great question. Yeah. So the question is what type of control structures we have for the ones the 3 of the ones that are not in the corner of the image here. And one question is if they are water gates, and that is a system from AgriDrain where a control structure is it's a different design. It's buried below the ground surface, nothing sticks up, and it's all controlled from the downstream most control structure. In this case, these are not water gates. They are regular control structures, and they do extend all the way to the surface. And we did that because this is part of, we are doing monitoring, and we are monitoring each of those control structures as well. Yeah, great question. I think that's all. We'll take the next, please. And so just this is just a few key stats here of this particular field. So 147 acres. Again, there was a homestead, a little bit of land came off. We had a grass strip on one side of the field. So it's not a full 160, but the 147. It is in a corn soybean rotation. Occasionally, he put in wheat, but he hasn't done that for several years now. We are at a 45-foot spacing on this one. That is narrower than we typically would in that area. We'd normally be at 60. But when there are different reasons for that. One of them was when we thought we were thinking we were going to use it for sub-irrigation also, but we ended up not doing that. All the laterals are 4-inch diameters. The drainage coefficient is 1/2 inch, and we talked a lot about drainage coefficient. And what the drainage coefficient is, that is a number for the capacity of the drainage system to drain water off the field. So that means in this particular case that this system is designed such that it'll drain up to 1/2 inch in a 24-hour period. So that means that, say, if we have 1 inch, if the soil is saturated, we have 1 inch of water, for example, is sat on the surface, we have 1 inch of water too much, it would take 2 days to drain that water. That's what the drainage coefficient means. And so 1/2 inch, it's a little bit on the high side for this area, but that was what we went with. Again, a 3/8, as Dave was mentioning earlier, is more common. The soil is a silver clay loam, the top 3 feet, and then we have just clay below that, extended below. We did a little boring up there, and we went to 15 feet, and it was just clay all the way down, and it probably continues for, I don't know, maybe hundreds of feet even, I don't know. Old Lake Agassiz, lake bottom there. Just some of the results we are seeing. This is for the first 4-year period from 2017 to 2020. Just a comparison between the controlled drainage, and that is all the green bars, and then the free drainage, which is, I can't even see what is that, bluish, okay, or blackish, whatever color that is. For some of the different water quality parameters we're monitoring for. First, over on the left, the amount of precip, we average about, over this period, about 24 inches. So again, as Warren said, substantially less than in this area. The next one, subsurface drainage, we have seen about a 13% decrease in the volume that we are draining over this period, or reduction in drainage from 5.6 inches to 4.9. But it varies a lot by year. Some years almost no difference. Other years, it's almost half the drainage from the controlled drainage.
Yala?
Yes.
Are these annual numbers?
Oh, thank you. The question is if these are annual numbers. These are based on the water year also. So they are annual, but offset following the water year. The reason we use the water year, or one of them is that really when you look at soil moisture and the impacts on the following growing season, it's really the fall that sets up what's going to happen the following spring. Because if dry fall, well, then obviously you have more water you need to replenish in the spring. Or if it's a wetter fall, well, that will help you if you have a drier spring. And so that's why we want to start the water year in the fall to kind of capture the fall conditions, because that has a huge impact on what's going on.
It's usually October 1st through September 30th.
Yes,
Yeah.
yes, yeah, thanks. Yeah, October 1st to September 30th. Nitrate, what we're typically interested in, and again, this is on pounds per acre, about a 22% reduction in nitrate losses. And then we have the total killed oil, total nitrogen, also a similar reduction in nitrogen. Then we have our phosphorus, and now the numbers, they round to 0. They are not 0. I'm going to talk about that in the next slide a little bit, but it's very, very low values. We can compare that to some of the numbers that Tim showed earlier, where across the Discovery Farms was about a pound, a little less than a pound give or take, of phosphorus loss per year from when you have surface runoff. But here these are substantially lower numbers. And then we have the total suspended solids, typically how much soil is moving out. And surprisingly, we have seen somewhat more soil in the controlled drainage. And we think it has to do with installation, because it was in that first year, the first couple of years, we really saw more of that soil. So either there might have been a little hole or just our soil getting into the system during the install. But that does have an impact on the phosphorus numbers, since phosphorus typically a lot of the phosphorus is absorbed through the sediment. So if we take the next slide, please. Because the question we often get is that yes, clearly this has a benefit for nitrogen or nitrate, but how about for phosphorus? So what I'm showing here is the amount of phosphorus loss in pounds per acre over on the y-axis on the left, and by year for the 4 years. Controlled drainage are the 4 on the left, and for 3 drainage, controlled drainage are the ones on the right. And we can see the total phosphorus. So that's the total amount of phosphorus that is dissolved in the water and is absorbed to the soil. Has been higher on the controlled drainage than on the conventional drainage, whereas the dissolved phosphorus has been similar, but tended to possibly be a little bit higher on the controlled drainage side. For the sediment, again, the total phosphorus, a lot of that is there's sediment that has gotten into the system somehow. So that's why those numbers are higher. But we also speculating that when we are having a situation where we are fluctuating between saturated and unsaturated conditions in the soil more frequently than when we're in a conventional system, that could change some of the solubility of phosphorus. And so there might be a short-term impact on the amount of phosphorus that we're seeing kind of to the detriment of controlled drainage. But it's something we're watching. And again, this is just one location. And so we're real curious to see if we're going to see a similar pattern here. But again, all these numbers are far lower than the 1 pound surface runoff that we see without tile. Take the next, please. All right, just going to end a little bit of talking about some of the outreach we have at this location. When we started, we set up tried to develop a strategy for that outreach. And there wasn't really any revolutionary new things, but one of the first things we wanted to do was to engage both the local groups and the collaborators in the project from the start, just to kind of help spread the information about what is going on. And then we wanted the project to be farmer-led. So it's Jared is on the picture over here under a sign that we had made about the project, talking at a field day we had, and he's just been phenomenal, really interested, great at hosting people on the farm. We've been leaning on a lot of partners for the information. So even though there's the Department of Agriculture, that's sort of the lead organization, but we certainly want all the other partners to be part of it. And then we've had a lot of collaborators involved in the field work. So when we are up doing the field work, even if it's, you know, running a shovel or something. Well, we've had people from NRCS and others come out and help just to get a feel for the project as well, but also to help kind of spread the information afterwards. So that has been a really good approach, we think. Take the next slide. So just a picture of some of the leaders that we're working with, the farmers we're working with again. So on the right, there's Jared and his dad, Gerald, the two on the right, the two farmers we're working with. And then Don and Kim on the left from the Wilkinson Water Conservation District that helps collect the water samples and such. And then Amy Klobuchar, Senator Amy Klobuchar, visited the site there a few years ago. And so where this picture was taken, to where she came up to see the site, which we thought was really a good outreach activity. Take the next slide, please. So since 2016, we've given over 15 presentations to over 3,000 people about this site. 5 of them were internationally. We had 19 field days. We've been out at trade shows, both in US and in Canada, with booths. There have been trade journal articles, both in the US and Denmark. Next slide. One of them in the drainage contractor that highlighted this particular project in one of their editions. Take the next one. We had a journalist from Denmark that came over, toured Minnesota and Iowa, and from the largest ag trade journal in Denmark, and wanted to look at, well, what are some of the drainage conservation practices that we do here in the US. And so I took him up and he interviewed the Nordics here. And so nice, there was a 2-page centerfold spread in this newspaper that came out of that. So I don't know how everybody's reading Danish abilities are, but this is part of what came out of it. And just a picture from some of the field tours we've had. We had a group from 10 or 11 different states, researchers, students, industry folks and others that came out a couple of years ago and looked at it. I think, Tim, that's you in the corner there, isn't it? On that,
for sure, yeah.
Yeah. At least a different shirt you're wearing today, but yeah. So it was a great field trip. That would take the next one. I think one of the perhaps highlight we've had as well is that we other than that Senator Klobuchar, we hosted another group from the U.S. House a couple of years ago, and you'll recognize the individual there in the white shirt, former Representative Colin Peterson, and then next to him, kind of to the side, is Kevin Kramer, senator from North Dakota now. And interestingly, the individual in the blue polo there is Glenn Thompson from Pennsylvania, and he is currently the chair of the Ag Committee in the U.S. House. And so they all came out and looked at the site. And then it's Mary, the lady in the back is Mary Podol, the state con. She's still state con in North Dakota. She retired. And then Kathy Pullman, the then state con in Minnesota. But she's not. She went to another state. But it was really Colin Peterson that set this meeting up because he wanted his colleagues to see what controlled drainage was about. And it was interesting because Glenn Thompson, when we were out, we're looking at the control structure and looking at how this works, and said, now I understand what it is you're talking about. Because he had just heard about it, seen it on pictures and stuff, but just being out there, to Warren's point earlier, when you're actually out in the field seeing it, just really makes a big difference. So I thought that was really interesting to host those. Take the next slide, please. All right. Just for more information, Carl mentioned this already. There is a multi-state collaboration of industry, drainage researchers, and others that form that as part of a transformingdrainage.org group, where there's a lot of information about controlled drainage. And so I encourage folks to look at that website. That Transforming Drainage group has morphed into a larger group called the conservationdrainage.net network. That has some additional information. And we're having our annual meeting next week in Easton, Maryland, where we will be focusing on implementation. So how do we get more conservation drainage practices implemented? And it is in Easton because it's close to DC. They're working on the Farm Bill. The hope is to, we have some of both the agency and congressional staff and others come out to join us to engage with some of all the researchers and industry folks that we have there. So that's going to be great. You can both attend virtually or in person. They go to the website there for details to register. Next slide, please. Okay, so that was just a recap. So just a little bit of background about the project we have in the Red River Drainage Water Management Project. Gave a little bit of introduction to the project, 147 acres. We found so far 13% reduction in the volume of drainage, 22% reduction in nitrate load losses. And then I'll talk about some of the outreach activities that we have. So with that, I think we'll take the next. So in closing, I think this is super exciting that we now have two sites that are sort of set up in a similar way. We can compare some of the results, and I think they're similar enough that we can compare many of those. And I think many of the objectives we're looking at are similar, both in terms of collecting meaningful information and outreach activities. So I certainly look forward to that collaboration.
Yes, Yaba, I have a question for you. From your knowledge based on this project and knowing more of the climate here in southern Minnesota, do you anticipate like that reduction in flow do you think we'll have more of an impact with controlled drainage just because there's more water here, or what are your thoughts on that?
Yeah, that's a good question. I would speculate that you would have more of an impact here, because the overall amount of flow you have is greater, and you have it during times of the year where there's not a crop on the field. So I think on the balance over, more than 1 year, yes, you would have more of an impact. But certainly if you just look at a single year, all bets are off. But yeah, I would think your impact here would be greater than it is up north.
Potentially.
Yeah.
There's a question online. Is there a maximum or minimum recommended spacing between tile lines to have the most efficient controlled drainage system?
I don't, not necessarily, because as I think we heard from the panel also that when it comes to spacing, it really depends on, well, how much water you want to drain and what soil type you have. And those are really the two key factors. We did hear suggested earlier that to maybe increase the responsiveness of the controlled drainage system, you could increase your drainage coefficient, and that would typically be, you would be either having a narrower spacing, or you would size your mains a little bit larger so you have a little more capacity. So that a person certainly could do that, kind of maybe over-engineer it a little bit for the responsiveness, but it's really again the drainage coefficient and the soil type, and how deep you want to go and such. Those are really the key determinants.
Shouldn't really matter between conventional or controlled drainage.
Right. Yeah.
Another question online: is there a berm around the field or each of the tile treatments, or how many acres is the watershed that flows into the field that would affect the water monitoring results?
That's a fabulous question. Yeah, that is a very good question. So we do not have it bermed, because the field we have is sloping east-west, so it's sloping towards the Red River, I guess. And so the tiles just run right up the slope, if you will. And so if we have surface runoff, that doesn't really move from one to the other. Of course, in practicality, if we do have a big rain event, it's not completely flat, and so we have observed we can have a little bit of interflow from one to the other, but we do not expect that to. We do not think that causes us a significant difference in the results.
Sure.
What's the other half of the question?
How
big the watershed is. That field is it is its own watershed. We do have some water running onto the field, kind of from another field, but that is running onto that. That was I don't know if you saw it on the image. We have a grassed waterway in essence on the western side of the field that has a little bit of a swale, or like kind of a scraped swale on it. And so any water coming from other fields any surface runoff just runs along across that drainage, or excuse me, the surface grass waterway there. So none of that water gets onto the tile treatments.
Sure, great. What are the nutrient management practices and yield history on those treatments, and how do they impact the water monitoring results?
Oh yeah. Yeah, I didn't talk about yield as much. Based on records from the farm, and let's just look at the yield monitor, kind of historical to now. It does look as if that the part of the field that we have controlled drainage tended to be the highest yielding part of the field, just because it's a little bit lower in terrain, maybe a little more, slightly higher clay content. But if we factor that in, we are seeing on average in corn about an 8 bushel difference yield advantage on the controlled drainage compared to the free drainage. Soybeans a little more varying, but 1 or 2 bushels. It's not that much. And so if you look at it from that standpoint alone, that yield increase at this particular location does not pay for the controlled drainage in and of itself, if you only look at yield. But what's also important to look at, well, there are other benefits as well, both in terms of fertilizer. You are losing less of your nitrogen through denitrification, so you can put a little bit less nitrogen on. Wear and tear on equipment, is that it is clear, especially during harvest time, but also at planting, that where we do not have, especially comparing to where we do not have drainage at all, it's always, the combine always makes ruts, or can make ruts. Planter makes ruts. You have more soil compaction, just more wear and tear on equipment. Whereas certainly the tile, whether it's the free drainage or the controlled drainage, you don't see that because the soil is drier. So you don't have that. And remember, a combine is a $600,000-$700,000 machine. And so once you start pulling that through the mud and stuff, it does make it. There's some costs to that as well. So that really ought to be factored into.
Great. And then lastly, who paid for the tile and installation? I think you covered that in part of your project partners.
Yes. Yeah. So it was a grants from the USDA and RCS, from the Department of Agriculture, the Buffalo Red Watershed District, and then everybody else that was listed provided, again, labor, materials, or other in-kind support.
Great. Are there any questions in the room? Perfect. Well, thank you, Yaba.
All right. Thank you. Appreciate it.
All right. I'd like to thank everybody that joined online.